Hello and welcome to our conductivity experiment. In this experiment, we're going to have 3 parts. In the first part, we just determine if something is a strong or a weak electrolyte. In the second part, we're going to connect that with different molarities, different concentrations, and different type of salts. And in the third part, we're going to measure the conductivity in a series of dilutions. Okay, let's start with the first part. So conductivity is being measured with this conductivity meter, and if you see closely here, you will have a scale which is either microsiemens or millisiemens, and then a number below, that's the temperature of the solution. So for example, here I have just DI water, and if I dip this instrument into DI water, what we see is that the solution is about at 22 degrees, and it has a measurement of conductivity of 2 microsiemens, or 1 microsiemens even. Okay, so I have here a calcium carbonate solution which is saturated. You can see that it's saturated because it has some calcium carbonate on the bottom. So if I dip that in, and we can read the conductivity, the conductivity is at slightly higher. So it's at 130 microsiemens. And then let's clean that. So that was calcium carbonate. The next solution we're going to look at is sodium chloride. Sodium chloride, let's see what the measurement says. It says it's 10.2, and now if you look at the scale, it says microsiemens. So it went up from microsiemens to millisiemens. So this is millisiemens. Let's clean that again. Next is acetic acid. If you look at acetic acid, the reading is 51.5 microsiemens. Next reading is glucose. It's the same molarity of solution, it's just different kind of types of solution. So if you dip this instrument into glucose, we read about 7 microsiemens. That is very low. That's close to DI water. Let's see if it's depending on if it's a glucose or a fructose solution. Here I have the glucose or sucrose solution. Here I have the sucrose solution. And when we measure the conductivity, it's still very low at like 10 or 11 microsiemens or 12 microsiemens. So that was the fructose. Next, we want to measure the concentration, the conductivity of magnesium chloride. The magnesium chloride solution, let's dip that in here, wait a little bit until it stabilizes. What we read here is actually 16.2 millisiemens. 16.2 millisiemens. And last but not least, I took sodium hydroxide. And if you dip that one in here, let's see if it's measuring it. Oh, it's pretty high. It's at 17.65 millisiemens. So all those solutions had the same concentration of solute, but the difference is in conductivity. And you now want to identify which one is strong, a weak, or a non-electrolyte. Okay. Hello, so in the second part, we're gonna measure the conductivity of sodium chloride solution, 20 milliliters of a 0.1 molar sodium chloride solution. The measurement is, let's see, it's 10.45 millisiemens. And we're gonna now also measure side by side 20 milliliters of the same concentration magnesium chloride solution. So the magnesium chloride solution, also 20 milliliter of a 1.1 solution. Oh, that's higher. That's 15.96 millisiemens. Okay, so what we're gonna do now is we're gonna add 20 milliliters of water to each of those beakers and see what changes. So I'll just add some water, pretty much filling it up to 40 milliliters. I use DI water. DI stands for deionized water. So in this water there are no ions. The ions are removed by ion exchange. So let's see what happens with the conductivity once I diluted those solutions. So sodium chloride was around 10 millisiemens. Let's see what it is now. Aha! It's now at 5.53 millisiemens. Let's see what happens in the other solution. So there was about 15 to 16 millisiemens. So now we're gonna add that here. And it's now at 7.88 millisiemens. Great. So you want to go to part B and fill in that table with the data you just saw, and there are some calculations you want to do for that measurement. In part C, we do a dilution and measure the conductivity as it changes when we add more and more water. So we start with 20 milliliter of the sodium chloride solution. That's a clean glass. We just add 20 milliliters. It's about here. We already measured that concentration solution in the previous example, but let's just repeat that measurement. It's at 9.89 millisiemens. Okay, so what happens if I add 10 milliliters of water? I use this burette to add water to this solution. First 10 milliliters. And let's see what changes. So now the concentration is at 5.42 millisiemens. Just going to continue adding 10 milliliters of water. Now I added another 10 milliliters. Just kind of stir it a little bit. And the measurement now, it's 3.66 millisiemens. Another 10 milliliters added. Stir it a little bit. 2.71 millisiemens, 73, 75. So far we have added 30 milliliters of water. Let's add another 10. There we go. Stirring it. So what's our measurement now? 2.15 millisiemens. We add another 10 milliliters of water so that the water volume we added so far will be altogether 50 milliliters. Let's stir that a little bit. And the measurement, oh, it's switched off, but we're gonna. Oh, so now it's switched scales. So now it's 1,936 microsiemens. Okay, we need to add a few more milliliters of water. We're going to continue using that burette. Need to refill it. It only contains 50 milliliters. There we go. It's pretty exact. So now we're going to add another 10. We will have added a total of 60 milliliters. Let's see what it does. See, the conductivity continues to drop. It's now at 1,669. Let's add another 10 milliliters. Stirring it. Becomes more and more volume. 1,473 microsiemens. And the last addition to a complete volume of 80 milliliters of water. So after this addition, we have added exactly 80 milliliters of water. Last measurement, let's see what it does. Let's stir that here a little bit. And the measurement after addition of 80 milliliters of water is 1,298 microsiemens. So these data points you want to add into part 3, the data report. You want to calculate the molarities and the contents of moles of sodium chloride. So we started with 20 milliliter of 0.1 molar sodium chloride, and we added 8 times 10 milliliters of DI water and measured the conductivity at each addition. I hope you found that interesting. It's going to be a nice graph, hopefully, when you graph those data. Have fun.